Right, so this is going to be a short one. Who here writes server codes? Yeah, that's a fairly substantial number. Do you have any data validation in your server stack? Pretty much everyone. Cool. Okay, so Accord is an open source data validation library that we use at Twix and developed at Twix. It's sorry about that. Fully open source. You can come on. Yeah, some technical difficulties. Right. So it's an open source data validation library that we developed and open source Twix. It's freely available, obviously, for you to use. I hope it's pretty well documented, and that's what I'm going to showcase. So to start with, I have a dream, and in my dream, data validation is almost trivial to implement. So in this case, in this example, we have this case class of person that has just two fields, first name, last name. And I would like to be able to specify my validation rules in as simple a way as possible. So in this case, I have here an implicit value person validator. So validation is a case class in Accord. It is a type class, sorry, in Accord. I define a validator over the type of person. And the way I actually define validation rules is I have this, I give a name to a sample object. Let's call it P for person. And then I can write p dot first name is not empty, p dot last name is not empty. And that is the premise that we started off with. And the reason we did that, so in comparison, is because we have a legacy Java stack, probably the same as most of you who have migrated to Scala. We used to use JSR 303, which is called beam validation. So Apache bval is an implementation of JSR 303. And that sucked, and I'm going to showcase why. But first, let's complete the picture with usage. So how is it used? Well, basically, I have this validate function that is static. I give it a person, and if it validates, I get back a success object. Trivial. More importantly, what happens when validation fails? So I validate a person who has no first name, but does have a last name. And what I expect to get back is some sort of failure model, right? So I get back a failure with a set of violations, things that have violated the rules that were predefined. And in this case, I have the value empty string that violated the constraint must not be empty, and most importantly, it has a description. And in this case, the description is the name of the property that failed validation, which is first name. So this is literally what we started off with in terms of design goals. And it ended up being an open source library called Accord. So, contrast to beam validation, which a lot of you probably know. Right? Beam validation is annotation based, right? You import javax.annotation.blah, and then you have these at size, at not null, etc., etc. Various constraints that you can annotate your fields with. Now, that kind of works fine in Java because Java has a very limited, expressivity in its types. But really for Scala, it doesn't work so well for two reasons. First, because these are, because it's intended to work on Java beans and it uses reflection, then you need to explicitly specify what it is that the annotation annotates, right? So it could be a getter, it could be a setter, it could be the field. In this case, it's the field that we're interested in because that is how beam validation actually does its processing. So you have this really, really uncomfortable syntax to work with: add size, add field, not null, add field, etc., etc. So it's really messy. It's very hard to compose. So if, for instance, you have a field that is an option of string, then you don't get any out-of-the-box support for options, obviously, because that's a Scala concept. But if you want to compose this notion of size limit with this notion of does this option have a value, you actually need to define an annotation. And defining annotation in Scala is also not particularly fun because you only get compile time annotations that get erased at runtime. Beam validation is a runtime reflection mechanism. So it actually becomes very, very hard to compose validation rules with beam validation. And it's also incidentally ugly because you work in Scala, that means you have to annotate with this at field stuff. It just adds a lot of complexity to your domain classes, which really, really, really sucks. With a core, the same validator would look like this. You have your address validator, and you literally have one rule per line, right? And it's a pretty fluent DSL. So for instance, your address sample object, a.tag, has size, smaller or equal to 100 and is not null. Or if it's an option, you can do a.address, or if it's collection, same thing, .each has size, etc., etc. So you get this fairly rich domain-specific language to define your validation rules in a pretty concise manner. And because it's a type class, it's not part of your domain class definition. So you can have your case class, and then your validation, and then anything else that has to do with the class. And it's not all intermingled. Contrast with ScalaZ validation, which is sort of the go-to solution for a lot of Scala people. Well, there are fundamental differences in philosophy between ScalaZ validation and core, but they boil down to the fact that ScalaZ validation obviously is part of ScalaZ. Crucially, it relies on ScalaZ idioms. So if you've actually tried to use ScalaZ validation and you didn't just copy-paste an example and try to work with that, you would have run into something like validation NEL, which is an alias of validation, which is an alias of, it builds on this stack of ScalaZ idioms and concepts that you may not necessarily be familiar with. And then you get the applicative functor syntax, construct your object. It all gets very, very complicated unless you're already invested in ScalaZ. So if you do not want to learn ScalaZ, really, this is not the solution for you. On the other hand, ScalaZ validation is actually very powerful because it's so abstract. So you can plug it in, you can do all sorts of interesting stuff with it. But once again, you have to learn the stack. A core, in terms of design principles, is designed to be extremely minimalistic. It has literally zero external dependencies. It's very small. It's got a very straightforward API. It's domain specific, right? It deals with validation. It's not this cute construct on top of a very massive library of concepts that you may or may not be familiar with. In terms of architecture, and I'm not going to go into too much detail, basically a core comprises 4 parts. You have your API, which I've shown you at the beginning. You have a combinator library, because matchers is, we had to come up with our own word, right? You can't just use matchers. No, we had to invent our own word for it. So we call them combinators for whatever reason. You have a DSL for defining validation rules, and then you get a macro that actually transforms your validation rules into type classes. Now, what do macros have anything to do with it? Just a quick, okay. First off, in terms of features, you get all these things. You get Boolean matching, you get equality, numeric matching, ranges, strings, all the things that you would expect in a sensible matcher / combinator library, pretty much you get out of the box. Why macros? So this is how you define validation rules, right? You'll notice that there are no strings here. But the resulting object actually gives you 2 things. It gives you an implicit AND between these 2 things. A validator in a core is entirely declarative, right? It doesn't actually do anything in of itself. It's just a function from your type to the result model. So the macro, the first thing it does is it takes all the rules and wraps them in a nice AND combinator to save you the trouble and the ugliness of having to do it manually. But more importantly, it generates descriptions. So if you remember the sample result I've shown you, it had the string first name in it, describe the thing that failed, right? The only way to get at it is through compile time, basically reflection, through reasoning about the result of compilation. And the core does not do any runtime reflection at all. So that is why a macro is used to actually analyze your code and figure out the right description for properties that you're validating. And you can obviously override it with an explicit description if that's your bag. In terms of features, type safe, 0 dependencies. It supports Scala 2.10 to 11. It actually, this is an old slide deck. It actually supports 2.12 as well, even though that's a bit wonky because it's pre-production. It supports Scala.js. It's Apache licensed, fully open source. It has built-in integration with Scala Test and Specs2 and Spring. The Spring integration is actually a little bit rough around the edges because there aren't that many people interested in it, thank God. But if you need that and you have some ideas on how to improve it, please do get in touch. And in terms of a core, that is all I have. So if you want to check out the library, You can obviously Google it, or you can go to wix.github.io/accord. There's a full-blown website with documentation. There's a Gitter channel. Any contributions, comments, feedback, more than welcome. And that's it for Accord. Thank you. Questions? Yes, sir.
Can you please touch a little bit more on integration with test frameworks?
So the question, the request really was, can I touch a little bit on integration with test frameworks? I can. It's actually pretty simple. You get a set of matchers that allow you to test your validations. So you can run a validation, get a result, and say, result should be a success or should fail with a certain constraint that had been violated. It's not, it's not huge, right? But it's useful in case you actually want to run unit tests on top of validation results for your objects. Future plans include a whole bunch of stuff, internationalization and stuff. One of the things I'm actually considering is adapting Specs2 or Scala test matchers to work as Accord validation rules. But I don't know that that actually makes, actual production use case sense. So no one has actually ever requested it. It's just my own thing.
Any plans regarding Scala check?
Do we have any plans for Scala check? Plans? No. Ideas? Not really. Certainly no objections, right? So if anyone comes up and says, hey, I think this should be supported, then we can have a discussion around that. So if you think that would be useful to you, hop on the Gitter channel, start a discussion. I'd love to have it. Any other questions? Okay, cool. Right, so I had actually a bunch of other submissions. I sort of assumed we'd be voting and stuff, but I guess that didn't happen. So really I have 2 things on offer. I can do 1, 2, or none. So show of hands, anyone interested in 20 minutes on how storage works, hard drives, mechanical storage? Okay. Oh, seems like far less than half the audience, so let's skip that, I guess. Another thing I can do is a condensed version of a talk I gave a couple days ago contrasting Java, basically trying to answer the question, Java 8 is out, is Scala still relevant? Obviously, since I'm here, the answer is yes, but there's like actual examples of things you cannot do with Java that you might want to do in Scala. So is that interesting? Okay, that seems to be a bit more involved, so let's go with that.
Do you have the slides for the hard drive talk?
For the?
Hard drive talk?
Yes.
Are you sure that will put them online somewhere?
Yeah, I haven't uploaded to SlideShare yet because SlideShare has a weird issue with PDF imports, but ping me, I'll send them to you by email or whatever. Okay, so I'm going to run through this without the live coding stuff, just to give you a bit of an idea. Yes?
Can I please close your
Can I close my laptop? I can. This will be a bit confusing because I'm used to the presenter view, but fuck it. Okay, any other questions before I actually said anything with, worth asking questions about? Awesome. Okay.